Today we are going to discuss about what is big data and what is AWS and what are all the services that we are in AWS as a data engineer. So before starting the session, I would like to know is there anyone worked on AWS or any big data services? Did anyone worked on data services or AWS? Okay, I will take it as no then. So, what what is data engineering? So basically, data engineering is processing, building, and analyzing data. So in general, in recent times, from the last couple of years or 5 to 10 years, there is a rapid growth in artificial intelligence. So we are seeing that we have ChatGPT, Google Bard, Gemini, all these services are coming up, and there are a lot of other applications where artificial intelligence is being used. So, uh, and also along with artificial intelligence, there are a lot of applications which are growing exponentially. So, uh, growing in number of applications, we are also seeing the growth in data. So earlier, when you go back to time in like 15 years or 20 years, there are minimal number of applications. So the data is very less. The data is managed in the traditional way. Even if you see in any organization or in a government organization or some other organization, most of the data is being managed in traditional way, like using papers, Excel sheets, and all. But once the IT is evolving, AI is evolving, and application development is evolving, the data is becoming, I mean, growing exponentially. So that means every year we are seeing, every day we are seeing terabytes of data, incoming terabytes of data. So we need to manage all of them, all of that data. We need to process that data. We need to build proper applications using the data, and we need to build reports using that data. So uh, in order to process that, we are building some tools that we have services available. So earlier, we have traditional SQL Server, Postgres, Greenplum, or Oracle. We have these traditional databases where it is using some uh, like your own servers. You will be having some your own servers, and you will be creating some databases in there, and we'll be storing the data in those servers. You are processing there, building that data there, analyzing the reports, I mean, building the reports and analyzing those, and doing the business in that on-premise servers itself. So, but that requires a lot of maintenance. So, you are owning your own servers, right? So that requires maintenance of that server, maintenance of that database, and everything. So that's traditional. That is the first step in data engineering. I mean, uh, before evolving of this cloud and big data. That is the traditional way where we are maintaining the servers, the database, and uh, handling the data in on-premise server. So once the data started becoming huge, I mean, once the data is growing, uh, those traditional SQL Server or Oracle is not sufficient to process the data. So they might be sufficient, this traditional database might be sufficient to handle data in terabytes. What if the data is growing in petabytes, uh, like a 10 TB of data every day or 100 TB of incoming data every day. So those cannot handle the processing because the number of nodes will be restricted. So the server might be having only 4 nodes, 8 nodes, or 16 nodes. But we need more than that to process this much huge data. So that's where big data comes into picture. So we have how to map, reduce, introduce later on. after some time. So Hadoop is a file system. MapReduce is a type of job where we are running our Spark application. So Spark is nothing but a framework where we will be writing our code in Python or Scala or Java using this Spark framework, and Spark is built on top of this Hadoop and MapReduce. So how this Spark and big data works is, so it will have its own dedicated storage system and server. When we build a big data job like a Spark job and run it on that server, so it will need some number of nodes. So in traditional servers, what happens is the number of nodes will be fixed. Like SQL Server, let's say if I have a server with 4 nodes, the nodes are fixed. But coming to big data, I can change the number of nodes. I have a server with more number of nodes. So let's say I have 128 nodes available. I can use any number of nodes based on my job requirement. If I'm submitting a simple job, I can request for one. If I'm submitting a bigger job, I can request it for 10 nodes. So it's like scaling up and down and processing huge data, running the big jobs. So that's why it is called as big data. So we'll be doing processing for huge data, building reports on huge data and analyzing all those. So that's where big data comes into it. So even the big data is using the traditional way, like having your own servers, creating your own clusters, maintaining them, and maintaining the storage, everything is again manual. So there, there comes the picture of the cloud services where the maintenance is less. I mean, AWS will be maintaining the storage. I mean, the amount of storage, the number of nodes, servers, clusters, everything will be maintained by AWS service. So uh, what we will do using AWS is we just request this uh, resources that we need. Let's say I'm in need of some 10 nodes to run a Spark job. I will just go there, create a new job, and request 10 nodes from AWS resources to run that Spark new job. And AWS will be providing me that 10 nodes, and I will be running the job. But in traditional big data, if I need to use the 10 nodes, I need to have my own cluster with 10 nodes, and I will be creating a cluster, and I will be submitting my Spark job. So as we discussed, big data was introduced when the data volume is getting increased exponentially. So we'll be able to handle a lot of data at a time. So uh, it will become easy if we are processing huge data at a time. So it will be easy for business analytics to make decisions, or we'll be getting real-time analytics. So even further back, let's say if you want to process the 10 TB data in SSIS, it will take some time. Like it might take 2 hours, 3 hours, or 4 hours. But in Spark, it might take only 5 to 10 minutes based on uh, the job size, data size, and everything, considering the scenarios. So, so that's where the reports will be built on real-time scenarios. So, building a report on the data which was processed for 5 hours compared to building a report that is processed in 5 minutes. So there is a lot of difference, right? Between 5 minutes and 5 hours. So SQL Server is taking 5 hours, RSS is taking 5 hours, and Big Data is taking 5 minutes. So processing time reduced. So we will be getting the reports in real time, like 5 minutes only. Earlier we used to get in 5 hours. Now we are getting in 5 minutes. So that reduced a lot of time dependency, and it became uh, the real time. So risk management and security, we'll see it everywhere, like even in SSS or Oracle server, we'll have our own security measures, and even in the big data, we'll be having security risk management. So once if the job failed in between, uh, or if any node failure while the job is running, it will be assigning new nodes, and the data won't be lost, and processor data won't be lost. Uh, the data replication will be there, and everyone cannot be able to access those nodes. We have these security measures implemented, and we can further implement our own security measures. So, is everyone clear so far? Hello, am I audible?
Hey, yes, Srikanth.
Is it clear? You want me to go in this way, or you want me to change the way of uh, discussion?
Yeah, it's clear, Srikanth.
Okay. So we are not going in depth of any topic today. This is a demo session, so we won't be going much deeper. So we are just uh, discussing on a high level amount of everything. So what is data engineering? What is big data? What is AWS service? And we'll be discussing one or two AWS services. So as we discussed, growing amount of data, we have some challenges like the storage cost, security, data quality, governance, network, everything. So we'll be facing a lot of issues. So to resolve all of them and to rectify all of them, uh, we have big data engineering. Everything is taken care in big data. So as we discussed, if a job is taking 5 to 6 hours in SSL, that data, that processing will be reduced when we run the same job in big data, and the management will be very much less. So infrastructure, we will be facing infrastructure issues and data security. So so if the data is growing exponentially, uh, so let's say today I'm getting only 1 TB of data every day. So then we'll receive 1 TB of data. So the data security can be implemented. So after 6 months, the data, uh, the incoming data size is increased to 100 TB. So in that case, there might be a possibility that we might be uh, compromising our storage system, or some other persons are using, some other users in the same organizations are trying to access the same data, some data which we should not access. So that we need to take care. So there are a lot of constraints. So we cannot control. So there are scenarios where one user is having access today, and he should not access some incoming data in future. Like let's say for 1 TB of data, incoming data, he should have access. So in future, we might be seeing 10 TB of data from different sources or different applications where the user should not access. Uh, so in that scenarios, we need to implement additional security measures. So uh, these kind of things, when the big data is growing, we need to see, we need to handle, and the network bandwidth and latency. So the data is increasing while processing, will be shuffling the data between nodes. Even in SSIS or somewhere, we'll be having data partitions, right? So while processing or doing some joins or aggregation, the data will be shuffled across nodes. So uh, if the data is very much used, that shuffling will take too much time. So if your node is having only some memory and the data is very much used, the shuffling will take time. The network will not activate and the latency will be increased. So that also we need to have a scalable thing. So to handle all of these things, cloud services comes to picture. So the scalability, network latency, all these will be reduced once we come to AWS. So what as a data engineer, what we are going to do in general. Uh, in general, what data engineers do is data engineers build data pipeline. So if it is a data migration service, let's say in recent times, most of the organizations are moving on-premise to cloud system, where their existing system might be somewhere, uh, SQL Server will somewhere. Now they wanted to move from traditional on-premise to cloud service. So they need to build this data pipeline to move existing data from on-prem server to cloud service. So to build that pipeline, they need services, right? So they need either a new service or one-time data load from existing system. Once that data is migrated from on-prem to cloud service, they need to build another pipeline which will be integrating the data from actual application to the cloud system. So here there are two things to understand. The first one is uh, migrate existing data from database, I mean traditional database to cloud service. The second one is so you will be getting data to that traditional, right? So you might be having a application, let's say you have Facebook and you are using SQL Server as your data warehouse. So if a new user created or if a user did something, that data will be stored the database, right? So if we wanted to migrate from traditional database to cloud service, initially we need to migrate all the data from this database to uh, the cloud service. And the second thing is, once the data migration is done, we need to point our application to use cloud service. Like if there is any new data coming from Facebook, we need to insert that into warehouse and we need to use whatever the data we migrated to cloud service. So we are getting rid of traditional database. So you understand, right? We will be having two pipelines. One is migrating the existing data, and the second one is the actual pipeline where our application is built on top of this cloud service. So we'll be building these two kind of data pipelines. So data integration is nothing but uh, like uh, from the application we'll be getting new data and the data will be stored it somewhere. So that is data integration. Infrastructure management, I mean the services we need to use, figuring out the services we need to use and creating those services in the cloud or on-prem and database design and optimization. That's the basic thing we need to do. Like we need to build the things, facts, tables, right? So we need how our database should look for the application. So that design and optimization and data modeling is something which most of the data engineers will do because data modeling, all these things are like data integration, everything, infrastructure management, database designing is one thing, and data modeling, data quality, and governance is one thing. Because all these pipeline building integration infrastructure. All these will only need as a data engineer, you need to know what are all the services available, what services we can use, and setting up that environment is one part. And the second part is data modeling, data quality, which is nothing but uh, I mean, which is something related to business. So I need to we will be having a lot of tables in the database, right? So we need to know what should be the end report. I think many of you might know the dims and fact tables. So where we'll be having some dimensions and fact tables in SQL Server. So we need to know which tables to join, what kind of data those tables will be having. So to generate this report, what kind of data we need, and uh, how can we join these two tables and which column. So these kind of things we'll be doing in data modeling. So data quality and governance is once those tables are built, once the data is populated in the strings, facts, and the master table. So we need to make sure whether the data is populated correctly as expected, as per the requirement. So for that, we'll be doing some QA, right? So some basic QA. So in general, data engineers will be doing that QA. It's not complete QA, but at least up to some monitoring, like whether the data is correctly populated, proper values are generated or not. All these things are will be taken care by data engineers. And also will be taking care of security implementations of the in the inside the database of the cloud service and the scalability of resource. Scalability is nothing but whenever we need additional resources, we'll be uh, changing our infrastructure a little bit or enhancing our infrastructure a little bit, and performance optimization, jobs, or database, or everything. So we'll be taking care of that as well. So next, after the data engineers build the entire system, there will be two users which will be utilizing the data generated by processed by data engineers. One is a data scientist and another one is a data analyst. So you might have heard data scientists a lot of times. They will be doing analysis. They will be predicting the things. Like machine learning, artificial intelligence, data visualization, all these things scientists will be taking. So the data we process as a data engineer, data scientists will be utilizing the data to do that analysis, modeling, and building their own machine learning algorithms and all. And coming to data analysts, so data analysts also utilize the data, but they won't be doing any predictions. So they will be doing the analysis, visualization, reporting using Power BI, Tableau, everything. They will be doing that thing. So sometimes data engineer will also be doing this data analyst part. So both the roles are different, but there are organizations where data engineers will be doing data analyst programs. So we might want to learn it later parts once the requirement comes in, but that will be pretty much similar to what data engineers do. So what data engineers do is set up the infrastructure, build the pipeline, generate the data, process the data, and store it in the data warehouse. From that data warehouse, data analysts and data scientists will be utilizing the data, and they are doing their own processing, visualization, predictions, everything. So whatever data analysts are doing, that will be done up to some part like querying, retrieving, analysis. All these things data engineers can also do, but data scientist part is a lot more different what data analysts will do. So there are other roles like data related roles like a database administrator, business intelligence analyst, data architect, quality analyst. So most of the things like business intelligence analyst is nothing but data analyst, database administrator. So uh, the database administrator role will also be played by data engineer because if you are using some cloud services, the entire things will be taken care by data engineer or DevOps engineer. So we can be doing that. Data uh, will be doing the data modeling part as well. So that will be sometimes played by data engineers. And the quality analyst also it depends on the situation. So we might be having a proper QA or sometimes data engineer will know how to do that. So is everyone clear or any doubts, questions?
Uh, Shrikant, this is Srinu. Can you hear me clearly?
Yes, yes.
So my point in my case, so I just wanted to have I wanted to have some questions regarding this entire coursework, how you're going to explain and all.
No.
So what's my point of view is like, well, are you going to teach this service by service? Are you going to create some project-based scenarios and you're going to explain the services in the project and you're going to
So,
feed us with the.
the initial plan is to go service by service.
Mhm.
It might change depending on the inputs given from you. So, if most of the people here are needed to know like the real-time scenarios, we can uh, work in that way as well. I mean,
Okay.
at the end of the day, once we are done with the service, we will be doing some real-time scenarios.
So,
Uh,
how many real-time scenarios can we expect from the course in point of view?
so, the we are doing it in a major thing like streaming service. We are planning to get a real-time stream. So nowadays, most of the organizations are migrating, right? So we
Yeah.
are
Mhm.
doing migration for from on-prem to cloud service using the three real-time scenarios. The same migration work in three different ways.
And
I mean, using
yeah.
services.
Okay, so we can expect at least like like 5, 6 scenario-based projects from the course, and
As of now, as I mentioned, we got one scenario like the migration, and that will be covered like other things like big data, job development, streaming, and other using data migration service. We have this AWS services where we will be most of the time we will be using. So those things will be covered. So if you have if you want to uh, discuss about any real-time scenario, you can bring it up and we can discuss it. So
uh,
I need to get some time before discussing about the scenario. Need to analyze that from my side. If you have
yeah,
any idea, you can share and we can discuss on that.
all right, that's good. And one more thing, I just wanted to make sure about this. So we are staying in United States, and we were like eagerly waiting for the job opportunity in case if something happens. Like we wanted to pick it up very quickly. So what's my point of view is like at how much level of point that we are going to make it for an interview kind of you know how much time we're going to spend on the interview point of view to prepare for this. Like
So if it is solely for interview,
mhm.
uh, no one will be asking like do this and in the interview, right? So they won't
Yeah,
be expecting you to do hands-on in the interview. So they will be expecting you to answer theoretically.
yeah,
So the first thing is uh, if they are going to ask any scenario-based question. So for that scenario, you need to know. what kind of services we can use. At least
Yeah.
two services maybe if available.
Yeah.
Let's say
Mhm.
if you are consider the migration from on-prem to cloud service. If they are asking any
Absolutely.
questions on that,
We
you
use
need to know.
RDS data migration. Yeah. True, sir.
Yeah, you need to know we can use Kafka, Blue, Kafka, and I mean solely Kafka as a third-party service and storage in AWS. You can use AWS Blue. You can also use a DMS for migration, data migration, and also you can use Kinesis. You can use EMR. So we have a lot of services. We can use them independently. We have four or five courses. So you need to understand like that. So they're asking what are the ways that way we can migrate from on-prem to cloud. You need to mention we can use when these are all the services based on constraints like cost, maintenance, all these things. We can go for any service. That kind of understanding we need to have while you are preparing for it.
Okay. And like apart from the AWS services, what are the other services we're going to learn from this?
So it will be mostly AWS only because
Okay.
we are expecting we might be having some big data knowledge and SQL knowledge. So those will be sufficient for learning AWS.
So we are not going to involve in Scala and all this Kafka and all.
No, those are different, right?
Yeah, I just wanted to make sure about that.
A database also.
No, that is from Azure. We are not.
Actually, AWS on database is this course.
It's
No, no. Azure is different, AWS is different. So we have Databricks in Azure, but
Data lake
we have
means also including or not.
yeah, data lake we will be discussing. What is data lake? What is lake house? We are discussing.
Okay, actually, I want to not a theory in particular.
Yeah, data bricks is different, and how Databricks is in Azure, we have Glue in AWS. So both are similar, but both are in different cloud. Databricks is
Actually, an EDA in database and data lake.
no, Databricks is completely different. Databricks is related to Azure. It is not
Actually,
related to.
I am working project in data lake, but we are going to Databricks as same data in copy or paste.
So data lake, so it is a concept where we are going to use everywhere, like in AWS, Azure, Google Cloud, everywhere. We can build data lake, but Databricks is a service where we are going to build our jobs. So data lake is a place where we are storing our data and building our data. Databricks is a place where we are utilizing the data from data lake or creating jobs that will build this data lake.
So my question is, uh, if we are not using Databricks, so Databricks is generally used to build pipelines, and here in AWS, what tools we are using, and are we going to cover any tools and practically doing hands-on of creating one example pipeline using AWS services? Are we going to do that during this course
Yeah,
so
we
that we
can
can do some
do that.
hands-on?
So there is nothing to do with the Databricks in AWS. We don't have that service in AWS. So, but AWS have Glue, which is similar to Databricks.
So Glue
So
will be used
whatever,
to build a pipeline job,
uh,
right?
like I said, we can use any service. We can use EMR. We can use Glue. We can use DMS. We
Okay, so
can
my question is, part of this course, what is the plan?
so
Do we have an example pipeline going to be built and
yes,
that we can
we have
practice?
one. We have one pipeline in plan, but that requires some cost. Like the services are little bit costly. I mean, it requires some cost, right? So we need to take care of that also. So we are coming up with a plan for building that pipeline. So we are doing that migration pipeline.
Migrate one again for migration pipeline, we like you said, the migration pipeline is from on-prem to cloud. So
Yes.
on-prem, how are we going to do it practically when we don't have on-prem system?
So you
We
can
just
have
maintain
your own,
files as input,
you
that's
can
it.
you can have your own SQL server installed in your local machine, right?
Okay.
We can use that as on-prem. We can just create some basic tables there, and we can use that test tables there. We can
Okay.
use that
So
as on-prem.
database migration.
Yes,
Okay.
you can just install SQL server on your local machine. You can create some tables, and you can use DMS or Glue or create an EMR instance and submit as part to build this pipeline and create a data lake in AWS S3. And if you want, you can also create a warehouse in Redshift or somewhere, and you can build that pipeline end to end. But few of the services are costing us.
Yeah, Redshift, yes, Redshift is will include cost.
Yeah. So we are seeing what other services we can use to get you to get you people the hands on like more hands on so that it won't cost more. So we are exploring on other services also. So for now, these are the services, and if you get any service that after is offering a free time which we can use for our hands on, we will share it with you.
Will you be sharing any, PPTs of, let's say, hands-on, step by step, so that we can,
Yeah, once we
you will
get to
be
that point,
explaining it in the class, you will doing on the live, or how it will be.
yeah, we'll be doing both. So once we get to that hands-on point, we'll be sharing, we'll be showing it in real time as well as we'll be sharing it.
And one more thing, Shrikant. Hello.
Yes, yes, yes.
Yeah. So at some point of time after this course and all, after this course, we'll be able to give this data engineering associate exam. It's like it's gonna to the main version is gonna to release in April. So we'll be capable of giving that exam.
So which exam?
So data engineering, AWS data engineering, it's going to release in April, the main version. Now its beta is going on, so the main version is going to release in April. So we'll be capable of giving the exam.
AWS Data Engineering certification you're talking about?
Yeah.
Yeah, you should be able to clear that exam.
Uh, yeah. Mhm. So as you're discussing about this RTS and data migration, apart from that, what are the main extreme things we're going to discuss in extreme level, apart from the data migration services and all?
So we are going to discuss each service individually. Like we are going to
Okay.
discuss EMR, EC2, Redshift, RTS, and IAM roles, Lambda, SNS, SQS,
Mm-hmm.
step functions, do workflows, everything we are going to discuss. And there might be whenever we are discussing few services, we'll be touching other services like Kafka, third-party services like Kafka, Airflow,
Mm-hmm.
even Spark, along with Scala or Python. We'll be discussing a little bit on that one. So
Okay.
we are not
So
going to have it.
go into deep in right.
Yeah,
Yeah. Gotcha.
they are. Uh, we'll be discussing on a high level. We are discussing on third part of data.
Okay.
I think, are we going to cover all these services in a generalized way or with some real-time scenarios?
So that I have already answered. So at first we are going to discuss what this service is going to do and how we are going to use it. And then once we are done with the discussion of services, uh, we'll be discussing some real time.
No, actually, if someone have like 3 to 4 years of experience in any other technology and if they want to switch to data engineer role. Can this course will be helpful
Yes,
with the content?
yes, definitely this is helpful.
Also, I have a question on timing. I mean, the duration of the course. So I think it is a 45 days course, and looking at the content, it looks quite overwhelming. So is it going to be covered within 45 days, and then
Yeah, yeah,
including the hands-on?
yeah, 45 days will be sufficient for all these topics to discuss and hands on. So if there is any extension, we can, if 45 days is not sufficient, we can take it slow and we can extend it further.
Okay, thank you.
Yeah, 45 days will be sufficient.
Okay.
So, so my question is, Srikanth, will you give excess of time if in case if you need any other information related to the ongoing program or ongoing project if you are discussing about?
Sorry.
So will you give some excess time if in case apart from the class, will you give some excess time if you wanted to discuss a project related issues? If ongoing, we need some more practical experience uh, apart from the class.
Yeah, if you have any doubts apart from the class, if you get any doubts or something, you can just ping me or ping the group if any group is ever created. You can ping me there or you can ping me. I will be
So are you working from India or it's like you're working from any other?
I'm working from
Okay, gotcha. So is there any other person who's going to take care of this course as well? Like you said that we are planning to do that. So this is your coursework or else like someone also will be involved in this course?
currently, I'm the only one taking care of because involving multiple people might confuse you.
Yeah.
I might be discussing one topic today and the other person will be discussing it in a different way the next day. So it will be very much confusing. So for now, the plan is to I am the plan is I will be taking care of this asset. So if
Okay.
any other person is involved, I will let you
Right.
Yes, I have a question, sir. Do you have any real-time project so we'll be able to put in our resume, except from the real-time migration project? Do you have a different project?
yeah, you can. So whatever the real-time scenarios that I am going to discuss in these topics, the real-time projects that I have already worked on. So I have worked on a couple of real-time AWS projects, which are migration only. So those are already work projects, so we can tweak them a little bit and we can use them in your application. Any other questions?
Yeah. So tomorrow, in this tomorrow session, what you're going to cover?
So we are starting from uh, the beginning. So tomorrow might be the first session. So we'll be starting what is AWS and why AWS. So from that point we will start. If you have any suggestions, so we give this one as a priority. You can share that and we can tweak our course. So if most of the people knows what is AWS and why AWS. We can straight away go into services.
All
So
right.
it all depends on how you are going to take it. So how most majority of the people.
All right.
So if everyone is knowing why AWS, all of you are here to know to learn only few services and real-time scenarios. There is no point in discussing why AWS, what is AWS, and all.
Mm-hmm.
So it all depends on the suggestions from you. And we are also expecting the suggestions.
Srikant, can you please explain bit of your professional background experience and the type of projects you worked so far?
Yeah, so far I have worked on like four projects from the beginning of my career. The 6 years of data engineering, I mean, completely into data engineering from the start of my career. So from the initial days, I started working on big data. So for the first things like all the all the four projects are migration projects itself. So the first one is migrating from Greenplum to uh, AWS Cloud and Snowflake. So that is done using the third party like the big data Hadoop and big data services. And later on, I migrated another cloud from Oracle to AWS. Third one is again SQL Server to AWS using Kafka. And the final project is uh, in my migration from SQL Server, I mean RDS to Redshift using AWS Glue, Lambda, and SNS, all these other services, using other services, mainly focusing on AWS Glue. So here are there, I have used almost all the services that a data engineer is using in AWS. I think I have used all of them. I work with Spark, Scala, PySpark, Snowflake, uh, Redshift, Oracle, SQL Server, and yeah, programming languages, Scala and Python. As data engineers, we only need mostly Python, and SQL is the main thing that everyone should have knowledge on that. So I have used SQL each and every project. Yeah, and the domains also are like most of the domains are healthcare domains. So one of them is retail. So three healthcare domains and one retail.
Maybe that would be good for today. Shrikant will discuss some more tomorrow.
So I just wanted to know whether the timing is fine.
Yeah, it's absolutely. It's like for me, it's okay. Like I don't know the rest of the team.
So 8 a.m. IST is fine for everyone.
8 a.m. IST, you mean?
Indian time.
Oh, Indian time IST. So this is the same time you're gonna do like half an
Yes.
hour. Yeah,
Yes.
yeah, yeah.
Any question?
Hello,
Yeah.
hello, Shrikant. Yeah, this is Komal here. I have another question related to data engineering. So, I want to know like how much market is with Azure and how much is with AWS. And if someone has already done Azure Data Engineer course or classes, what will be the common things and what, like for example, I can get out of it? Will it be an add-on? Is there any common tools which is available, which is used across the three cloud? So that is my question. And if someone has already done, let's say, AWS Solution Architect Associate, and he was into Azure Data, he did Azure Data Engineering course, for example, me. And if I want to now do Azure AWS Data Engineering course, will it be helpful? Yeah, so this is my position. I just want to know the market also, and like, yeah.
Yeah. So we have three cloud services available: AWS, Azure, and GCP, which is Google Cloud. So Azure and AWS is from long back. So the first cloud service which market is used is AWS. So then Azure came into picture, and both of I mean three cloud services have their fair share in the market. So three cloud services are being used extensively. So AWS and Azure top the list as GCP is the recent one. So both have their fair share. So we can't say AWS is being used more, Azure is being used. So in some parts, Azure is being used more, and in some organizations, AWS is preferred. So as you mentioned, you already worked on Azure. You might be having some knowledge on what is database and what is file system in Azure, everything, so the security, access, user access, policies, and all. So those things again will be having AWS. The naming will be different. So in Azure, if you are the storage is like I think it's blob storage, right? So the storage in the card is blob storage there. Here you will be having the SD as storage. The naming differs, but the storage is same. And in Azure, will be having Databricks where you will be running your big data Spark jobs. And here you will be having where you will be running your big data Spark jobs. And in Azure, you will be having SQL Server integrated. Here you will be having um, its own Redshift, and also you can use RDS for your SQL Server. So you have the same things, the same concept between everything, even in the GCP, Azure, and AWS. You'll be having the same concept, but the names will be different, and the way of approach we need to use them is a little bit different.
Okay, and will my solution architect associate certification will help me and knowledge will help me in this course?
Uh, so sorry, you have already done AWS SAA certification.
Yeah, solution architect associate. Yeah,
Yeah,
will that
I mean,
help here?
yeah, that will be helpful in business case scenario. So most of the preparation for that certification will be based on real time scenarios. So this is the scenario what you will do kind of stuff. So that will be helpful to figure out what services you are going to use and a minimal amount of questions how you are going to use that service. That certification you will understand when you are working in real time scenarios.
Okay. What about after this course, if you want to appear for the data engineer, AWS data engineer exam?
So if you want to take AWS data engineering certification, this course will help definitely. If not 100%, at least 80 to 90%. So that 10%, you need to understand how the previous the questions being asked and you need to prepare in that. So we are not sure, right? So how the questions are there in the data engineering certification, whether it's completely real-time scenarios or is it technical questions. So if it is technical and mix of real-time, yeah, this course is definitely going to work.
No, it's
And if
completely scenario-based questions, right?
it is completely scenario-based questions, you need to understand the scenario and you
Mhm.
need to understand what services and how we are going to implement that in AWS. So the implementation and all we are discussing it at service level. So we are not sure of the scenarios they are going to ask.
So,
So
one more thing. So, look, what my expectation is like, can you design a course? Can you design this course on the basis like, I mean, like, we have a guide for the data engineering, AWS data engineering certificate. So, can you design a course on the basis of that? Is it possible?
yeah, I will check that and I will design that. I will
Yeah, sure. So we need to have like a basic structure and idea. It's like they're like divided into four sections, and each section has different services and all, and it's included. So that's what we are thinking about.
yeah, sure. We'll take that into consideration as well.
Yeah, sure. Because it's easy to cover all the services, and the most importantly, which will be using in which. So it will be very easy to segregate.
Uh, so
Yeah,
I will cancel
yeah. Thank you.
that
Thank you.
job
Mhm.
session and we'll update the course plan accordingly.
Yeah, sure. Thank you.
Is everyone completely into data engineering or is there anyone part of data ops as well?
Yeah, I'm part of DevOps, mostly on DevOps side and cloud engineer also.
Okay. So you wanted to learn how to set up all these things or you wanted to only
Yes,
learn?
I would like to learn how to set up all this, especially in migration, because as part of some of the projects, sometimes they ask for migration data. So I would like to learn how to migrate all those data.
Okay. Yeah, we'll be covering the setup of the services we are discussing. Yeah, that will be covered.
So, what you are going to, what is the tomorrow's topic?
So the first topic. So as I said, like what is AWS and why AWS is the first topic that we are going to discuss. And if everyone is already aware of AWS and all, we can right away switch into other topics and services. Yeah, it will be the first
Yeah,
session.
probably we can get started with services, in my opinion.
Okay.
Hello.
Yeah.
Yeah. Srikant, actually, I just want to re-emphasize on the point on the practical learning. So, enough practical learning will be there, right? Enough hands-on.
Uh, Hands-on will be there definitely. For every service we are learning, hands-on will be there. But when you are doing hands-on for few services, there won't be a free direct available. So that will be costly. So that you need to consider. I mean, you understand my point, right? So whatever the
Yes.
service we are discussing, we are going to see it in real time. We'll be doing it. So apart from real time scenarios, so keep aside the real time scenarios. So if you are going to discuss about one service, we are going to see it in real time how we are doing it, and all. We are going to see it in real time. Along with the discussion, we can do it hands-on for that one particular service. But few services won't offer any free tier. So if you are creating some EC2 instance, we are not getting any free tier. So that will be costing us. So while doing hands-on, we need to keep in mind whether it's free tier or not.